Hi, my name is Dan Clark, and if you're looking to build a battery pack for your project, electric bike, electric motorcycle, electric car, go-kart, whatever, um, it can be really tricky to understand how the battery exactly works and how you need to put it together. So I've spent the last couple days researching this topic, and I've spent the last few weeks researching electric motorcycles in particular. It's the next project I'm going to be working on, and this is definitely one of the hardest parts to get. It is definitely one of the hardest parts of putting this thing together. Everything else is pretty self-explanatory, but this battery, you want to do it right or it's not going to be safe. So let's go over some physics real quick. So when you're starting out, you're going to see that there are a few different voltages that people use. I found that if you're using a motor under 5,000 watts, you're going to want to use 48 volts most likely. Now, how do we get 48 volts when the nominal voltage is 3.6 volts on most 18650 batteries and the maximum voltage is 4.2 volts? That's very far off from 48. So what we're going to need to do is we're going to need to connect 13 18650 batteries together into series. This is going to be basically top to bottom to top to bottom. It's kind of like a big squiggly line of connections. You connect the top and the bottom of one battery, then the top and the bottom of the next set of batteries. And that is going to not increase your milliamp hours, that is going to increase your voltage. So it's going to be 48 volts running at most likely 3,000 to 3,500 milliamp hours. So I don't like amp hours when it comes to talking about electric bikes. If you're comparing ones with the same voltages, then yes, amp hours is a good comparison, but really the better comparison is watt hours, because when I connect all those batteries together in series, of course that energy is not gone just to increase the voltage, it's still there. So watt hours is probably a better way to estimate the total amount of energy in the system. Volts times amps gets you watts. So for under 5,000 watts, like I said, that's going to be a 48 volt system most likely. You're going to want to make sure that you're selecting your motor first before you kind of decide on the battery system that you want. But I found for my situation where I want to use over a 5,000 watt motor that a 96 volt system is the better system to use. It seems like in the systems that are over 5,000 watts and the motors that are over 5,000 watts, using a higher voltage system makes the motor more efficient. You'll get a longer range with a higher voltage system than you will with a lower voltage system, especially when you go over 5,000 watts in my experience here. So that's going to be, instead of 13 batteries in series for 48 volts, it's going to be 26 batteries in series. Now these are going to be connected together with other groups of 26 or 13 based on what voltage you need. These are going to be connected together with other groups of batteries in parallel. So this is what's going to increase the amp hours of the battery. So I found that for an electric motorcycle, using a 96 volt system with 26 in series to get 96 volts, it's going to be 3.6 times 26 is going to get you around 96 volts. And I should say that when it's fully charged, it's going to be more than 96 volts, and when it's depleted, it's going to be under 96 volts. Now, when you have your battery management system, you're not going to want to fill up the batteries and discharge them completely. That will really wear down the lifespan of the batteries. So you want to try to keep that in a nice middle range in between that. And also adjust for any sort of weather conditions. So if it's cold, the batteries need to be heated up, and if it's hot, the batteries need to be cooled down. So you might have to have some sort of temperature management system in there. I found that for getting the range that I need on my electric motorcycle, which I'm targeting about 60 miles of range, I was looking to 60 to 120. It seems for 120, you're going to be spending about $2,000 on the battery pack. and for 60 I'm spending about 1100. So to calculate the range on an electric bicycle, I'm going to be giving two different things because this is what I researched. So I researched electric bicycles and electric motorcycles. For electric bicycles, I found that the amount of wattage that it takes to travel 1 mile on a electric bicycle that's going to be pedal assisted is going to be about 15 to 30 watts per mile. Now on an electric motorcycle, which is not assisted, is going to be about 40 to 100 watts per mile. So the faster that you're going, the more wattage it's going to take to travel a mile, because you have aerodynamic drag, which is going to mean that you're going to use more energy to keep that speed. So for the optimal configuration that I found with a 96 volt system was that it would be 26 batteries in series to get up to 96 volts, and then it would be 9 groups of those in parallel. That's going to be 234 batteries total, which is going to cost around $1,100. And that should get about 60 miles of range. So when we're trying to figure out range, it's going to be in watts per mile. You're going to want to do research on exactly what you're building and how many watts per mile that other people have experienced that taking. So with electric bicycles, for example, most people are reporting on forums that it's around 15 to 30 watts per mile. So the amount of energy that it takes to go 1 mile. On an electric motorcycle, which is generally going to go faster than a bicycle and it's also not pedal assisted, is you're going to take 40 to 100 watts per mile. Now the faster that you go, the more energy it's going to take to fight against that aerodynamic drag. So if you're going highway speeds, then expect closer to 100 watts per mile. If you're just doing city like I am, then expect around 50 watts per mile. Remember that the group of cells that you have in series is only to increase the voltage. It does not increase the amount of amp hours. So with 26 cells creating a 96 volt circuit, it's going to still be 3,500 milliamp hours. We're going to take 3.5 times 96 to get 336 watts per group of series, and then we're going to multiply that by the amount of groups that we have. So we have 9 total groups, and that's going to be 3,024 watt hours. Now we're going to divide that by the amount of watts per mile that we're expecting, so 50, and then that's going to get us a total range of 60.48 miles. So just some quick takeaways here. When you're wiring in series, that's going to increase the voltage by the amount of volts of each cell. Just take the nominal voltage and take the total voltage that you want and then divide by the nominal voltage. So when it's more charged, it'll be a little bit more, and when it's less charged, it'll be a little bit less, but it'll kind of average out to that 48 or 96 volts that you need. Parallel circuits are going to increase the amount of amp hours that you have. So that's going to increase your capacity. But really the true metric of capacity is watt hours, unless you are comparing like voltage systems. So if you're comparing two systems that are both 48 volts, then amp hours is fine to go by. But if you're comparing 96 volts versus 48 volts, you're going to want to go by watt hours, because those batteries don't just disappear when you put them in series. They are still there. Calculated in watt hours, that'll make it so much simpler, and it'll be much easier to figure out range from there. Remember that higher voltage systems are generally more efficient than lower voltage systems with higher current. If this video helped you at all with your battery planning process, I did my best to explain it. Please hit the like button and subscribe. I would really appreciate it. I will be talking more about electric bikes, and I will be documenting my entire journey building this thing and all the research that goes into it, so I can hopefully make it much more simpler for you. Thank you for watching so much, and have a wonderful rest of your day.